Hey guys, these are the lesson 4 distance on a coordinate plane notes. Make sure you're following along as you go, and you will for sure probably need to pause this to make sure that you have time to write this down. I will be checking to make sure your lesson 4 notes are completed. It starts on page, I believe, I probably should have looked this up first, page 13. Page 13 in your workbook just starts out pretty simple with what's the distance and the slope between 2 points. Now these points are nice because one point is the origin, so point A, you should plot at 0, 0. And then point B is at -6, 0, which remember the x-coordinate comes first, so it's saying go left 6, but don't go up or down. So I really want to know how far is it from this point B all the way over to point A. And because it's a straight line like that, you can count really easily. It would be a distance of 1, 2, 3, 4, 5, 6. So I'm going to say the distance is 6. We could also find the slope of that line. Since we put rise over run, from B to A or even A to B, it doesn't matter. You didn't go up or down. The rise is 0. But we just said we ran 6. And anytime you do 0 divided by anything, you're going to get 0. Horizontal lines, like my hallway, don't have any type of steepness to them. They have a slope of 0. We're going to next find another distance and slope, but now it's between that B that we already graphed and point C. Point C is at -6, 4. So it goes 6 to the left and 4 up. So I've got these 2 points that I would like to find the distance and the slope between. Again, straight up and down, we can count pretty easily. It has a distance of 1, 2, 3, 4 units. So I'm going to say the distance is 4. They are 4 units apart. And when I count rise over run, this time I rose 4, but I didn't run at all. We didn't go left to right. Just like my wall in my classroom, when you try and describe how steep it is, it doesn't really make sense. It has an undefined slope whenever it's vertical. Then we're going to get a little tricky on here. So again, we already said that this was 4. I should have marked it on here. We said this distance was 6, but now I'm not interested in either of those. I want to find the distance and the slope between point A and point C. What you'll notice when I draw this in is we now have a right triangle. And we just spent a whole lot of time dealing with right triangles. We can find this distance using the Pythagorean theorem. So I'm seeing 2 legs, 4 and 6, because those are creating the right angle. The hypotenuse would be x, since it's across from the right angle. So I'm going to square my numbers, 16 and 36. I'm going to sum those numbers and get 52. And because I don't see any directions saying round to anything, I'm not going to round. I know 2 goes in 26 times. 26 is a 2 and a 13. So my answer could be written, instead of square root of 52, it's square root of 2 times 13. When you find a pair of numbers, one of them comes outside the radical, leftover numbers stay in. So I'm going to say that the distance is 2 root 13. You cannot count something with a square root. The only way we could have ever done that is basically using this Pythagorean theorem relationship. I am still interested in the slope, rise over run, but you'll kind of notice we already have it written in. If I start at point C, you can think of going down 4, so it's got a direction now, it's negative, and then right 6. So I could say I went down 4, right 6, which when I reduce is -2/3. So the slope with that 4 and that 6 are what I used here, and then they're also what I had gotten from here and here. That's not going to be a coincidence. That's going to be really helpful information when we go to find the length of segments. So we have to get a little bit of vocab before we can really get into that though. So right below that, the vocab, the part of the line that has 2 endpoints and all the points in between, that's a line segment. We usually just call that just a segment. So here, I got a line. But if I say I'm going to start at this dot and I'm going to end at this dot and I want to include everything in between, that will be the line segment part of it. It matters how we name things in geometry. We're going to name them with 2 points, 2 capital letters with a segment symbol on top. So for example, this, I could call this X and I could call this Y. Therefore, the name of this segment, I put segment XY with a bar over top. So in the examples we just did, the segment that had a length of 2 root 13, well, I know it started at A, it ended at C, therefore segment AC had a length of 2 root 13. The one that was 6 long, well, let's see, it started at A, it ended at B. One thing to point out is I keep saying started at A, but it's just the same to say it started at B. So I could say it's segment BA instead. The order doesn't matter as long as you just say start and end. So on this example over here that I kind of sketched, if somebody had put like a W in between here, this is still the name of that segment. You don't just say, oh, it's now XWY. That is absolutely not correct. You have to use 2 of the points, start and end. You will never name it points in between. Then we sometimes will have segments that turn out to have the same length. Congruent is our geometry way of saying the same. So congruent segments are 2 segments that have the same length. We don't like taking the time to write the word congruent, so the symbol is an equal sign with a little squiggle on top. That was poorly drawn. Let me try again. So equal sign, squiggle on top. That looks the same. Whatever. I give up. So if I had asked for the length of segment AB on this one, point A is at 1, 4. So I'm going to graph that. Point B is at 13, 9. So way up here. As soon as it's not a straight horizontal or vertical line, if there's a slant to it in any way, you cannot count that. But you have some skills. You've spent a lot of algebra time counting rise over run. So that's what I'm going to do. I'm going to draw in this rise amount, and I'm going to draw in this run amount. And I'm creating for us a right triangle, because you can do a lot with a right triangle. So if I count, I just rose 1, 2, 3, 4, 5. So I'm going to label this leg as 5, and I know it's a leg because it's making this right angle. Then I'm going to count this leg as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have a leg of 5 and a leg of 12, and I'm not interested in a leg length. Whoa, what happened? I'm not interested in a leg length. I am interested in the hypotenuse's length. So that's what I'm going to do. I'm going to say the legs are 5 and 12, and the hypotenuse is x. So I have 25 when I square to 5, 144 when I square 12. I'm going to sum them and get 169, and because we made this one nice, when you get rid of the squared by square rooting, that's a perfect square. We now know that length is 13 units long. It's really nice when I give you nice small numbers, when I make it so that you can graph it. Shoot, when I just give you graph paper, that will not always be the case. So if you remember slope formula, this length of 5, this rise amount, we said it's the change in y. We had described it as y2 minus y1. And then the run amount, if you actually use the slope formula, was x2 minus x1. We're going to basically do that, and instead of saying, well, I have 5 squared and 12 squared, we're going to put in those subtracted x values, so that when you don't have graph paper, which there will be times I'm not going to give you graph paper, you still have a hope of finding it. So the distance formula is basically saying, okay, when you get done with the problem, for sure you have square rooted at the end. So there's this colossal square root to say, oh yeah, at the very end, square root all the stuff you were doing. So there's a big square root. In the square root, we basically need to say at some point you got a horizontal distance of some subtracted x's. And because it's the Pythagorean theorem, you took that distance and you squared it. And you did the exact same thing with the y's. You found the vertical change, the rise amount. So you probably didn't subtract them, you probably just counted them, but when you can't, you subtract it, and after you subtract, you squared it. And the Pythagorean theorem says take those squared legs and add them. So we'll add them. So that's the distance formula that I'm going to expect you to know, have memorized, and be able to use on upcoming quizzes, like the one I think we're going to take next week. So flip your paper over, please. Flip your notes over. You are on page 14 at this point. I want to find the distance. Now, I did not give you graph paper. You are capable of finding your own graph paper, but nobody in their right mind wants to graph 2590, so we're not going to. We're going to find the distance, so I'm finding the length of segment CD. That's what it means when it just gives you those letters. I'm going to find the length of CD with my distance formula. So the distance formula, which I'm going to rewrite because you don't have memorized, and the more you write it, the more likely you are to learn it, is x2 minus x1 squared plus y2 minus y1, also squared, being added and put inside a square root. Every point is made up of an x and a y, an x and a y. But you have 2 points, so I'm going to call this one my first points, and I'm going to call this one my second. That order is arbitrary. I could have made C the 2's, but everybody gets an x and a y, so that at some point you should be subtracting the negative 15 and the 25. So I'm going to do negative 15 minus 25. That has to be in parentheses. After I subtract, I will square them. Same thing for the y's. I'm going to take 90 and subtract 40. That has to be subtracted before I square them. Now, if you had made a different choice for the 1's and the 2's, your order might be different. But after we subtract and then square them, we all end up back at the same place. So that doesn't really matter that much. So negative 15 minus 25 is negative 40. I need to square a negative 40. Negative times a negative is a positive. So I'm getting positive 1600. And again, hopefully you have your calculator. If you get good at this, you don't have to show much work because you're doing it in your calculator. 90 minus 40 is 50. 50 times 50 is 2500. You will notice at this stage when you're about to add, if you don't have positive numbers, you messed up. They will always be positive numbers. When I add them, I'm going to get the square, why isn't this writing? Square root of 4100, which, since it ends in 2 zeros, I know 100 divides into it 41 times. 41's prime, but I know 100 has a 10 and a 10, so we're going to have a pair of 10s at the end. Or you keep breaking it down and say the 5 and the 2's. So instead of 4100, I'm going to say 2 times 2 times 5 times 5 times 41. So a 2 comes out, a 5 comes out, a 41 stays in. The exact answer is 10 square root 41. But you also need to have the rounded answer. If you don't have a calculator, you are not capable of doing this. Get a calculator. 64.0 is the rounded to the nearest 10th answer. Make sure you're actually typing that in so you can see the rounding on that, but it's 64.0. There's one more that's on here. It works the exact same way of what we just did, but I'll go through it anyway just because we need this setup practice. So let me change colors so it's not confusing. So same formula. I'm going to call this point x's and y's because every point has x's and y's. I choose this one to be 1's and this one to be 2's, but that is my choice. You could choose differently. But we have to square root. I'm going to subtract. I just realized I started with my y's. Technically doesn't matter, but just to be clear, I'm going to subtract 2 and negative 4. I'm going to subtract the 14 and the 6. Make sure you will always start with subtraction, even though that was a negative, what the heck? Even though that was a negative 4, you still subtract it. So you end up with a 6 squared and an 8 squared. 36 plus 64, I'm going to skip ahead, is 100. That's a perfect square. The exact answer is 10. You are not able to give an approximate answer for that. I rushed through that one because I'm recording this at school and the bell's about to ring on me, but make sure you are actually running through this with me and getting the same answer, whether that's with your calculator, plugging in values. You have practice to go over this. We will spend another day on it, but you really need to make sure you are trying on your own. Try and be wrong because then you can actually learn. If you don't try, you're never going to learn it. So good luck, and I'll